So I have 15 amp source. This is 1 ohm. I changed my pens today because I figured I'll be writing a lot of stuff. I need a lot of space. I don't want to use big markers. That's 3 ohms. And now we have a dependent current source here. And the value of that 3I sub 1 and I have another resistor of 2 ohm on the top here. And I sub 1 is the current coming down here. This is I sub 1. I'm going to apply nodal analysis here. That's what we studied last time, which is what? Go to each node, not counting the ground, and apply KCL to each one. So let's assign current any direction you want it to go. Well, we have I sub 1 already plotted. We know this going in, this is going in. Let's make these currents, we'll call them what? I sub x, I sub y. Now, if I count this as the ground, notice the whole thing is the ground. That's including this point. That's the ground. I only have how many nodes? 2 of them. This is 1. Node 1, where's the other one? And this one, node 2. So here's the first equation, KCL at node 1. What is the current going in? 15 amps, and what's leaving?
15 amps.
I sub x plus what? I sub 1. KCL at node 2. The current going in? 3I1, and what's leaving? I mean plus, what else going to it? I sub x, and what is leaving?
I sub y.
I sub y. So how many equations by how many unknowns?
2 equations and 2 unknowns.
Try again. 2 equations, how many unknowns? 3 unknowns. So we can't solve them. We need to change everything back to in terms of voltage. I define I sub x as the current coming down. That means I sub x is going to equal the voltage at node 1 we'll call V1 here, and the voltage here we'll call V2. Is going to be V1 minus V2 divided by 1. Ohm's law, I equals V over R. I sub 1 is going to be this voltage, which is V1 minus this voltage, which is ground, divided by 2. And I sub y, I define it going in this way. It's this voltage minus that voltage divided by 3. V, what's that voltage? 2 minus 0 divided by 3. Now, if I put these substitution back into that equation, I'm going to have what? 15 equals I sub x, which is V1 minus V2 divided by 1. I don't need to divide it by 1. Plus I sub 1, which is V1 over 2. Multiply by 2. 30 equals what? 2V1 minus 2V2 plus V1, clean it, 30 equals 3V1 minus 2V2. This is equation 1 again. I'm trying to convert that from 2 equations by 3 unknowns to 2 equations by 2 unknowns. Let's take the second equation. 3I sub 1. What is I sub 1? V1 minus 0, which is V1 over 2, plus I sub x, which is V1 minus V2, equals I sub y, which is what? V2 over 3. What's my LCD here?
6.
6. Okay, 6. 2 will cancel. That'll be 9V1 plus 6V1 minus 6V2 equals what? 2V2? Is that 15V1? Minus 8V2 equals what? 0. And that's my equation 2. I have 2 equations by 2 unknowns. I gotta solve them. Now it's algebra. Here's the 2 equations. Let me write them down. 30 equals 3V1 minus 2V2. And the other one, 0 equals 15V1 minus 8V2. We can multiply the top equation by negative 4. And that'll give me negative 120 equals negative 12V1 plus 8V2. Leave the bottom one alone. And when you add them, gone. What do we have? Negative 120 equals what? 3V1. V1 equals negative 40 volts. If I know V1, can I find V2? 30 equals 3 times V1, which is negative 40, minus 2V2. That's negative 120. That's 150 equals negative 2V2. V2 equals negative 75, is it? The question, what's the power observed by the source, the dependent source? So let me look at that dependent source. Let's zoom in on it. This is what it looks like. This is the ground. This is V2. V2 is what? Negative 75. What that means is this voltage here, this voltage is higher than this by how much? 75 volts. This end higher than that by 75 volts. Find the power supplied, the question, supplied. So let's find I sub 1. Do we know what I sub 1? Do you know what that current going through it? I sub 1 is V1 over 2. And what was V1? Negative 40? Is that negative 60? Negative 40, that'd be negative 60. Which means what? The current's actually going to be coming which way? Down, right? Because it's negative. So what you're looking at is this way. There's a current coming down of what value? 60. There's a voltage here, minus to plus, of 75. You have a positive current entering the negative end. That's power supplied. And that's why they're saying the power is being supplied. The power is V times I, 75 times 60, and maybe you want to put a minus sign in the front to indicate it's being supplied. And what's 75 times 60? Some number. Is that 4,500 watts? So it's basically 4.5 kilowatts, and the negative sign tells me it's being supplied. So when you have a dependent source, nothing really, no surprises. Where the problem becomes a little bit tricky here, when you have a problem that looks like, let's take this one. Let me make it nice and clean picture. We looked at that problem before. 4K. Negative 3 amps going this way. $3K. 1K. Negative 8 amps going up there. We looked at that circuit before. Minus to plus, and this is 22 volts. And now we have 5 and we have negative 25.
Is it a 5K resistor or just
5K.
Okay.
Oh, no, there's none of these. Oh, I use K. I guess there were ohms. I guess none of them were Ks. I guess there are no Ks. 1 ohm. So all these are no Ks in them. Now, me personally, I'm not a fan of these minus currents going in. So guess what I'm going to do here? I don't like these minus, minus, and minus. I can change the direction of them. And I'm not going to redraw that again. And make that a plus. I'm going to change the direction of this and make that a plus 25. I'm going to change the direction of this and make that a plus 3. That's what I would have done immediately. Instead of using the negative values. Notice if I count this as the ground here, and this is V1, node 1, there's the voltage here is V1. This is V2. And you want to call this V3, go ahead. So V1, V2, and V3 looks like, I said it looks like 3 equations by 3 unknowns. But I'm going to have a problem. This is a sine current. any direction that you want. So if I do KCL at node 1, that's where V1 is. What is the current going in? Nothing. What's leaving?
8A.
8 amps, the 3 amps, I sub 1 plus I sub 2, right? While we're here, let's change everything to voltages. 8 and 3 will be what? 11? Moving to the left side, that's negative 11 equals. What is I sub 1? It's this, notice I define it going to the right. So it's this voltage minus that voltage over the resistor. This voltage minus that voltage over this. V1 minus V3 over 4.
Where did the negative 11 come from again?
3 and 8.
Okay.
Now multiply by 4 to get rid of the fractions. That will be what? Negative 44 equals V1 minus V3. That's the first equation.
Oh, you forgot the i's.
Oh yes, I forgot the i's. Thank you. I forgot I sub 2. I try and fit it on one line. Okay. Let's add I sub 2. And I sub 2 is this voltage minus that voltage over 3. V1 minus what? V2 over 3. I liked it better before, David. The LCD is 12. 12 times 11. Negative 132 equals 3V1 minus 3V3 plus 4V1 minus 4V2. Clean it. Negative 132 equals 3V1 plus 4V1, that's 7V1 minus 4V2 minus 3V3. EQ1. KCL, next thing is KCL at node 2. At node 2, the current N, 3, plus I sub 2 equals the current leaving I sub 3 plus I sub 4. Let's change everything. 3 plus I sub 2. What's I sub 2? It's V1 minus V2 divided by 3. Equals I sub 3, which is what? V2 minus the ground over 1 plus I sub 4. What is I sub 4? Can we write I sub 4 in terms of the voltages? Was it? How is I sub 4 in terms of the voltages? You're saying 22 what? That's a voltage. So what is I sub 4? That's a voltage, right? You can't. So it has to stay as I sub 4. So if your LCD for this is 3, 9 plus V1 minus V2 equals 3v2 plus what? 3I sub 4. 9 equals, if I move everything to one side, negative v1 plus 4v2 plus 3I sub 4.
So we put the I sub 4, we can have the written it in terms of like V2 and V3.
Can't. Ohm's law says I equals V over R. What's R? Right? So now we get V1, V2, V3, and we get I sub 4. So you know we got a problem. Well, let's look at this node, KCL, at V3. Let's see what's going to happen. Let me fold that paper there. This is V3. What's going into it? I sub 4 plus I sub 1 plus what? 25, and what's leaving? I sub 5. I sub 4, we can't touch it, gotta leave it as I sub 4. I sub 1 is what? V1 minus V3 over 4 plus the 25 equals I sub 5, which is what? V3 over 5. What's my LCD? 20. I sub 4 plus 5v1 minus 5v3 plus 500, I think, equals 4v3. Five v1, there's no v2 here, minus 9v3 plus 20I sub 4 equals negative 500. That's equation what, 3? This is equation what? 2. How many unknowns do I have? There's equation 1, equation 2, equation 3. But how many unknowns? V1, V2, and V3, and I sub 4. 4 unknowns. We can't solve it. We need another equation. Well, what does that 22 volt source tells me? That this end is higher than that end by how much? 22. So that source tells me that V3 minus V2 is equal to what? 22 volts. So how many equations that you have now? 4. And now you got to solve them. Notice I sub 4 here. I could have solved for I sub 4 and plug it into this. And that will give me, instead of 4 equations by 4 unknowns, substitution will give me 3 equations by 3 unknowns. So it looks ugly there. So is there an easier way when you have a problem like this? And the answer is yes. A little bit easier. Instead of dealing with 4 equations by 4 unknowns, I can solve this with 2 equations by 2 unknowns. How? Let me put it back there. Here we go. I'm putting the current in the right direction, 3 amps. Three. 8 amps. 1. 22. 2. This is 5. This is 4. That's the circuit we had, 25. This is my ground. This is V1 just like before. We said this is V2. And this one is not going to be V3. This is not going to be V3. It's going to be what? V2 plus 22. It's whatever this voltage, add to it, because this end is higher than that, add to it 22 volts. Now, this whole thing will be treated as what we call supernode. That node here is considered one node. All of that. You see the dotted line with the circle, that's a supernode now. That's the supernode. So we had currents going this way. We had I sub 1 going that way. We had I sub 2 going this way. We had I sub 3 going this way. And I had I sub 5 going this way. And I had I sub 4 going through that one. I don't have to write I sub 4. I don't need it here. KCL at V1. We did that. That doesn't change. There's no change here. What is going to that node? Nothing. What's leaving? 8 plus 3 plus what? V1, or let's go I sub 2 here, plus I sub 1. Negative 11 equals, what's I sub 2? V1 minus V2 over 3. What's I sub 1? V1 minus, but instead of V3, this is going to be what? V2 plus 22.
So did you combine the V2, the two nodes there into one node, or?
This will be treated as one node.
Oh, okay.
When I do KCL at this node, this will be treated as one node. Except the only difference, the voltage here and the voltage there is not the same. Normally a node has the same voltage. This end, the voltage is V2. This end is V2 plus 22. 4 and 3 is what? 12? 12 times 11? Negative 132 again equals 4V1 minus 4V2 plus 3V1 minus 3 times V2 plus 22. Clean it. This would be a minus 66. Bring it to this side plus. Four and 3 is 7 V1 minus 4 V2 minus 3 V2 is what? Negative 7 V2. That's equation 1.
How'd you get the negative 66? Did you add that with the? Oh, okay, this actually happened. 132.
All right? Yep. So now I'm going to do KVL at the supernode. I mean KCL, not KVL. KCL of the supernode. What is going to that node? This whole node. What's going to it? I see 3 amps going to it. I see I sub 2 going to it. I see I sub 1 coming from the top. Do you see I sub 1? It's going to it. I see the 25 going to it. And what's leaving? 3 and 5. $25 and 3 is what? 27? I mean 28. Plus I sub 2. What is I sub 2? V1 minus V2 divided by 3. Plus I sub 1. V1 minus this end, which is V2 plus 22 over the 4. What's I sub 3? V2 minus nothing over 1. What's I sub 5? V2 plus 22 minus nothing over 5. We definitely need a calculator here. LCD, 60 is it? I think it's 60. Sixty times 28, 1680. Plus what? That'll be 20 V1 minus 20 V2 plus 15 V1 minus 15 times what? V2 plus 22. 60 V2. 60 divided by 5 is what? 12 V2 plus 22. Maybe I can clean some of the stuff on each side. 1680. 20 and 15, that's what? 35. V1. Negative 20 minus 15 is what? Negative 35. V2. What's minus 15 times 22? That'd be a minus, not a plus. 15 times 22, 330 is it? Equals what? 60 V2 plus 12 V2 plus what 12 times 22? 264.
Can't you make that 72 V2?
72 was...
60 V2 plus 12 V2.
Yep, I'm going to put them together now, yep. So I have 35 V1. You said this is 72, right? When you bring it to this side, it becomes a negative. You can add it to that one. What's 72 and 35? 107. V2 equals. How about the numbers? 264, that'll be a plus 330 minus 1680. This will be minus 1085. If you don't like the minus, you can change it to negative 35 V1 plus 107 V2 equals 1085. And that's your second equation by how many unknowns? So instead of 4 equations by 4 unknowns, the same problem, we truncated it to 2 equations by 2 unknowns. See them right here? We have 2 equations by 2 unknowns. That's it. Now let me write them down.
Is that supposed to be like 86 or something? 1086?
5. Yep. So let's look at the 2 equations. The top equation says 7V1 minus 7V2 equals negative 66. The other equation says what? Negative 35V1 plus 107 V2 equals 1085. I can multiply this equation by what? 5 to make it, to cancel the V1? 5 times 7 will make it 35 V1 minus what? 35 V2 equals negative 66 times 5. Is that 330? Add the two equations. The right side is 755. 107 minus the 35. 72 V2. What's V2 equal to? $10.486, about 10.5 roughly. If I know V2, can I find V1? Grab an equation. 7V1 minus 7 times V2, which is 10.5, equals negative 66. $73.4, this number, if I carry all the digits. 7V1 equals what? 7.4, and V1 equals 1.06. So we found all that stuff.